Calculus! We are in AP Calculus Self-Check 6.2. We just spent 10 minutes going over number 5 from 2010. So these are the slopes that you'll need. You will need, wait, whoa, that one messed up as well. Okay, well.
So it only shows it in the browser?
It only shows it in the browser. That is weird. Okay, so those are the slopes that you need. You need 0 slopes for x equals -1, which makes sense because -1 plus 1 is 0. So you need those 0 slopes and all the non-zero slopes on the right-hand side. Those are the ones that are going to be a point. So this one has a slope of 1, slope of 2, slope of -2, slope of -1. This has a slope of 1/2, slope of 1, slope of -1, slope of -1/2. So if you get that side, that left-hand side, you get 1 point. Those two on the right-hand side, you get 1 point. How many points are we at so far?
We need that one, like, extended line.
This line is 1 point. That's the solution curve through 0, 1.
Oh.
Yeah, in the instructions, it did say, and I know that it was hard to see, to sketch the solution curve that passes through the point 0, 1.
I read it.
Yeah, I read it, and then I was like,
I don't think I actually read it.
anyway.
Okay, so it's okay. You missed that point. So you're at +2 right now.
No, I don't think I
Isn't it
did
plus-
it right.
For me, wouldn't it be +1 because I didn't sketch that line?
So, okay, so if you did these guys right here, that's +1. If you did these ones, and then I just look at the answer key so I can do it really fast, it goes 1/2, then 1/2, then 1, then -1, then -1/2. Then this one was, this goes to 2, so it's x is 1, so it's 2 over 2, so 1 and then 2, right? And then -2 and then -1. So if you did all of these, that's 1 point. If you did all of these, that's another 1 point. And then if you did this graph here, it should be an open dot at 1 because you can't actually have y equals 0, and then it should be a straight line down through those points. I have technology. What am I doing, Mr. Sindel? And then you should have a straight line that comes down through here. That is that solution. And you'll notice that the reason that it doesn't continue going up this way, I mean, you probably could have done it that way, but the x, or the domain of this, is just to -1, so you don't need this other half of the line. So far, so good? All right. Next, we're on to part B, and I did not give enough room, so I need to maybe fix that for next year. So for part B, you need to describe what's happening. So the way that I solved this one was I started by rewriting dy dx. So I said dy over dx, and that is equal to x plus 1 over y. X plus 1 over y. And I said, okay, well, set that equal to -1. And when you set that equal to -1, it's really set equal to -1 over 1. Cross multiply here, so y times -1 is -y. And that's going to be equal to x plus 1 times 1 is just x plus 1. Divide both sides by -1, and you get y is equal to -x minus 1. So the answer here is y equals -x minus 1.
I put x plus 1 equals -1, which
Yeah.
is equivalent. That's still right.
That is equivalent. Let's just check what the solution guide says. Description, yeah. That. So say it again, Ben.
X plus 1 equals -y.
That works, yeah. X plus 1 equals -y. You'll get the point for that. So give yourself that +1. Are there any questions about how to get that? Did you give yourself the 1 + 1? Did you get it? Rochelle, no? Arrow? No? Okay. And then we're on to part C. So this is the separate. And the separate is separate. There we go. This is a little bit easier than the last problem because you don't have to divide anything. So when I cross multiply x plus 1 times dx, I get x plus 1 times the dx. And then on the left-hand side, my dy is multiplied by y. So it's y dy is equal to x plus 1 dx. Right there, right away, we get 1 point. Separation of variables. So that, I don't keep alt tabbing. That already gives us +1, just right there. And then we're going on to integrate. Integrate. Okay, so when we integrate both sides, integrate y dy is equal to integrate of x plus 1 dx. Taxman, do we need them? Don't need taxman, so this is just y squared over 2 is equal to x squared over 2 plus x. And don't forget your plus c. How many points do we get for just doing that? So we did the antiderivatives correct, and so we got +1 there. So if you did both sides here correct, you got +1. And if you got your constant of integration, you got your plus c, that's another +1. So there's my plus c.
In this solving part, it means everything after it is wrong too?
Yep.
Okay.
Yeah, so once you make a mistake, that's the end of however many points you get. So did you make a tiny error already?
Yeah.
Ah, darn, this sinks. Yeah, just be careful. And then from there, what's next? Use the initial condition. So if you do your evaluate where you plug in 0 for x and -2 for y, if you plug those in immediately, you give yourself that extra point. I'm going to be doing the isolate step correctly. Actually, you can do the evaluate still. You can do the evaluate right now to just solve for c. When I solve for c, I'm going to get -2 quantity squared over 2 is equal to 0 squared over 2 plus 0 plus c. That's 0, which means -2 squared is 4. 4 divided by 2 is 2. So I'm left with 2 is equal to c, which is really nice. And then that brings me to my final step of isolate. I'm going to do it down here. Isolate. When I isolate, I need to get this y by itself. So I'm going to multiply this equation, everything times 2. And be careful here because c right now is 2. This c is 2. So I'm going to multiply that 2 by 2 since I'm solving for y squared. So I'm multiplying every single term here by 2. When I do that, I'm left with just y squared is equal to x squared, because the 2's cancel out for the denominator, plus 2x, and it's not plus 2 now because we multiply by 2, so it's plus 4. Now I need to take the square root of both sides. When I take the square root of both sides, I get y equals plus or minus x squared plus 2x plus 4 square rooted. And I have to decide whether or not to choose the plus or the minus. It's never both. It's always one or the other. So how do I test that? You have, what's up? It is negative because it's -2, and I'll show you what Rochelle just said in math. So when I plug in -2 for y, and I plug in 0 for x, this is going to be plus or minus the square root of 0 plus 0 plus 4, which means I have -2 is equal to plus or minus 2. Obviously, it has to be the negative, so my final answer here is y is equal to negative square root of all that x squared plus 2x plus 4, and that's what they got for the answer key, I hope, as well.
Again, I had an equivalent form. It's not the same. I had y equals negative square root of the quantity of x plus 1 squared plus 3.
Oh.
Well, I guess it's just inside the square root.
That's fine. That works. As long as you have that negative outside the square root, you got the point.
I got it right.
So if you got this thing, you get +1.
I got it right, but I forgot the negative.
You forgot the negative? Okay, you don't get the point then, sadly. Any other questions about scoring? No? Okay, at the very top of your paper, out of 9, how many did you get? How many did you get?
3.
3? You're passing. 5? Good job. That's above passing. Ben?
So counting it a little slow.
That's okay.
8.
8. Yeah, dang, that's really good. What was the point that you missed, Ben?
I was on B. I didn't do on A. I didn't do this
The line.
solution curve.
Oh, the solution curve. Yep.
I did it like a curve. It went like that. So it's just
Yeah. And then I think I originally did that too until I solved for B. And I'm like, oh, wait, it's a straight line. So yeah. What was the error that you made, Arrow?
Oh, I did some weird derivative stuff and not distributing properly.
Oh, just taking the derivative of x plus 1 correctly?
Mm-hmm.
Okay. And Rochelle, what was the mistake that you made, the major learning experience from today?
For B.
For B? Yeah, just setting it equal to -1 and then solving.
Yeah.
Okay, yeah, now you know for next time. All right, and that concludes our notes.